Assalamualaikum. We are from RAS1201E. So, we're going to present about our lab report for experiment 2, Newton's law of motion. So, this experiment was conducted by Sir Zaidi bin Zaini, and this is my group members. I am Nurul, Syuhada, Athirah binti Sharizan, and we have Nurun, Naja binti Kamarudin, and Siti, Alia, Maisara binti Rosidi. So first of all, this is the link for the simulation for this experiment. Okay, the objective of the experiment was to investigate the relationship between total force act on object with acceleration of the object and to study the Newton's second law of motion. Okay, we start with the procedure. For the non-friction surface first. Okay. First, when we click on this link, it will be open for this, and then we can proceed to force graph tab as shown in figure 1. So this is a force graph test. Okay, the second one, there are a few parameters that we need to set up before start the experiment. First, the object we used was the small crud. So we can choose the object here. And then for the friction, we choose the ice. For the non-friction surface, we can set it here. And then for acceleration graph, we can click on the acceleration button and the acceleration graph will be shown. And also the acceleration radar. Okay, then for the first data, we are going to apply 500 Newton for the F apply for the first data. So we can apply the 500 Newton here, and after all of the parameters was being set up, we can press the play button to begin the simulation. The acceleration A was recorded. The result was tabulated in table 1. And after the first reading, we must reset all of the setup by click on reset all button for the second reading. All of the steps above were repeated at least 3 times for each data. Step 2 until step 7 were repeated for another 9 data. Okay, for the friction surface, it same goes to the non-friction surface, but we change the friction to wood. We choose wood here. We also, for the first data, we also use 500 Newton for the F apply, and after all have been set up, we press the play button. The acceleration A was recorded. The result was tabulated in table 2. After all of this, these are done, the reset all button was clicked for the second reading. All of the steps above were repeated at least 3 times for each data. Step 2 until step 7 were repeated for another 9 data.
Okay, so this is the result for this experiment. Table 2.1 is the result for non-friction surface. We have applied force, friction force, and total force. To get total force is by adding applied force with friction force. For example, 500 plus 0 is equal to 500, and we just do the same for all another 9 data to get the value of total force. And this is the value of acceleration. Table 2.2 is the result for friction surface, applied force, friction force, and total force. To get total force is also by adding applied force with friction force. For example, 500 plus negative 219.4, and we get 206 as a total force. So we just do the same for all another 9 data to get the value of total force. And this is the value of acceleration. Analysis. Number 1, from the data plot graph for total force as a function of acceleration for non-friction surface. So this is the graph F total versus acceleration for non-friction surface. B total force as a function of acceleration for friction surface. This is the graph F total versus acceleration for friction surface. Number 2. From both graphs, state the relationship between the total force with the acceleration of the object. The formula is force is equal to mass times acceleration. Okay, based on Newton's second law of motion, there is a direct relationship between force and acceleration. The greater the force that is applied to an object of a given mass, the more the object will accelerate. So the relationship between the total force with the acceleration is directly proportional. Number 3, does the graph obeys Newton's second law of motion? Explain. Yes, the graph obeys Newton's second law of motion because the force value increases directly with acceleration value. When the total force increases, the acceleration also increases. Okay, that's all for me.
So we continue the next question. Number 4. Determine the gradient slope of the graph. What do the gradient represent? Explain. So based on the Newton's second law, force equal to mass times acceleration. So force divided by acceleration equal to mass. So we calculate the gradients of graph A and graph B using the gradient formula y minus y divided by s minus s. So we insert the value from the graph A. 900 minus 0 divided by 9 minus 0, we got 100. And also the graph B, we insert the value that we got the graph B. 606 minus 0 divided by 6.06 minus 0, and we got 100. So this presents the gradient slope of the graph is equal to the mass. Okay, the next question. Number 5. Using Newton's law of motion, prove the coefficient of kinetic friction between the small crack and the wood surface is 0.3. So Fs equal to ma, weight equal to ma. Mass of small crack equal to 100 kg, acceleration equal to 9.81 ms square. So weight 100 times 9.81 equal 981 Newton. So we calculate the kinetic friction coefficient equal to coefficient of kinetic friction times the Newton value from we got this. So 0.3 times 9.981 equal to 294.3 Newton. So and then we calculate the coefficient of kinetic friction equal to 294.3 divided by 981. So the answer is 0.3. So it is proven. Okay. The conclusion. As a conclusion, the objective of this experiment was learned that is investigating the relationship between the total force act on the object with the acceleration of the object and studying the Newton's second law of motion.